All right, apes class, we are talking about coral reefs today. So coral reefs corals cover less than 0.1% of the global ocean surface, but they are home to 1/4 of all of the fish species found on Earth. So that means that they are a phenomenal habitat, a really important habitat for marine species. There are two types of coral. The first is hermatypic, that's Hermatypic, and those are the corals that actually build the reefs that we think of when we think of coral reefs. So these are found in tropical waters only, and they're very sensitive. And then there are ahermatypic, which are non-reef building corals, and those are found worldwide, and we even have some off the coast of North Carolina. So their requirements for living are that they have warm waters, preferably, well, they have to be between 18 and 36 degrees Celsius, but preferably reefs are the most productive when the waters are 26 to 28 degrees Celsius, which is a very teeny tiny narrow range of temperatures in which they can be very productive, which comes into play later when we talk about climate change. They need shallow areas, usually less than 30 meters, because they need a lot of sunlight and they need those warm waters. So also in conjunction with needing a lot of sunlight, they need clear water. So if there are lots of suspended solids or nutrients that cause algae blooms, that can kill coral. And then they also need a hard substrate to grow on top of. So that usually is either igneous rock, which is rock formed from lava or magma cooling, and that's what the reef off of North Carolina is based on, or they can grow on existing carbonate reef, so existing hard structure that the hermatypic corals have already formed. They also need calm water, so not a lot of wave action, because they can easily be broken or detached from their substrate, and that will kill a coral. So when a reef is forming, we have planktonic larvae. So plankton are anything that is so tiny in the ocean that it can't determine its own path of movement. So the planktonic larvae are released above the coral reef, and then they just float along with the current until they find that ideal hard substrate. So either the existing carbonate reef or the igneous rock. And then they grow towards the surface of the water until they're creating a platform that's just below the low tide line, so that they're only exposed to air for a very short period of time every day. And so this growth takes thousands of years. They're very slow growing. And then after they've reached the surface, the reefs spread horizontally. There's a very important interspecific interaction that occurs in hermatypic corals, and it's a symbiosis between the coral polyp and an algae called zooxanthellae. And those algae live inside of the coral structure and photosynthesize and provide the coral with energy. And the coral is providing the algae with protection and nutrients. So this symbiosis is very, very fragile. It's very sensitive to temperature, to UV radiation, and to high nutrient levels. So high temperatures or UV radiation or nutrient levels will actually cause the coral to expel the zooxanthellae, and that will ultimately lead to the death of the coral because the coral is not getting those energy compounds anymore. And it causes what we call bleaching of corals. So they actually turn white because they're dead and they're not photosynthesizing anymore. So they're now just essentially a piece of seashell, same material that seashells are made out of. So corals are also a very important foundational species. They provide a structure and places for food to grow for many different organisms. So reefs have been recorded homes of over 100,000 species. So that's pretty crazy. And if you ever get the chance to snorkel or scuba dive at a coral reef, you'll get to see some of this beautiful biodiversity for yourself. They are very, very highly productive systems, even though that they are found in extremely nutrient-poor waters. So the corals can sequester a lot of carbon, and they hold on to it in their hard structures. And even though they're very highly productive systems, a lot of that primary productivity does not leave the coral reef. It does not float out into the ocean. It's recycled right there within the coral reef. And it supports many, many food webs, including food webs that are important to the economically important fish species. So a loss of coral means a loss of fish that are very important to a lot of economies, especially countries with very low GDPs. Fishing is a huge industry there. So some threats to corals include disease. They're susceptible to many pathogens and parasites, and they're even more susceptible when humans have damaged them. They're susceptible to storms, so the waves produced by hurricanes and other tropical cyclones can break the corals apart and destroys hundreds or thousands of years worth of growth. They're very susceptible to climate change. The increased carbon dioxide in the water turns to carbonic acid, and that dissolves the actual physical structure of the reef. The increased temperature of the oceans will cause the corals to expel the zooxanthellae. That causes bleaching. And then there's also issues with predation. So there's a sea star called the crown of thorns sea star, and it actually is one of the few species that eats the actual coral. And recently there have been several population booms of these crown of thorns sea stars, and scientists are still trying to figure out exactly why and how to manage it. Some ideas are that maybe humans have overfished the predator species of the sea stars, and another theory is that there are environmental reasons that allow for greater survival rates of their young. And then there's pollutions, nutrients, and sediments. So anything that causes like algal growth or suspended sediments in the water blocks sunlight from getting down to the corals, and so they can't photosynthesize, and those zooxanthellae die, and causing the corals to die. And another is some very destructing fishing practices that humans tend to partake in. So that includes fishing by dynamite. People will actually throw sticks of dynamite into the ocean to shock the fish and make them come up to the surface, and that obviously destroys the reef. People also will use nets and things that drag the bottom and just rip up the coral as they go, which is not great for the coral. So, in closing, as I've kind of touched on throughout the video, there's a lot of ecosystem services that corals provide, and that makes them a very important habitat. So some ecological services that they provide for animals are habitat and food for many, many species. So it's a very extremely productive system and very biodiverse. And then also economic benefits that benefit us is that it's a nursery and a refuge habitat for many fish that are commercially important to the seafood industry, and it's also important for recreational uses like diving and snorkeling, so that keeps dive shops and tour operators in business. So, all right, we will talk more about some other interspecific interactions and keystone species a little bit later.